Hey everyone, welcome back. So as you can probably see, it's a little bit of a different setup what we've got going on for this lesson. So I hope you guys can still hear me okay, because normally what I do is I have my headphones on plugged into my laptop, just because there's a microphone attached to them, and I don't know if it really does anything to benefit you guys, but when I play back the videos later, the audio seems to be fine, so I just haven't tried messing with that system since it works. But today, just because I'm a little distance away from my computer because of this board, I haven't plugged in the headphones, so hopefully there's no audio problem with what you guys are able to hear. And I hope that when I write on the board, there's no video problem with what you guys are able to see. Let me just make sure. Okay, I think you get the entire board just like that. So everything I write is going to be on this board, so hopefully nothing goes off the edge of the screen for you guys. My apologies for the slightly odd setup. This video and possibly the next one, depending on when I record them, will be in this setup with the blackboard here, and that's just because I am currently on my university campus. It is 5:12 in the morning, and it's just been a bit of a crazy night with trying to do some work and trying to record one of these videos just to get that out for you guys in time for class. So I'm going to get back on track with a more structured recording sort of schedule in the not so distant future, but for this video and possibly the next one, I'm just trying to get these out now because I got to get back to work after that. Anyway, what I was thinking is I've been meaning to get an assignment out to you guys just so you get a little bit of practice with graphing lines, but I haven't had the time to make that assignment yet. So what I figured I would do is we'll spend one more lesson graphing lines, but we'll try some of the more complicated examples. So for example, what we've done before is we've graphed things like y equals x plus 2 and y equals 2x minus 3. So we've graphed functions that look something like that. You don't have to write those down. Hopefully you can see those though. But we've graphed functions that looked like this. And what I was thinking we would do today is we'll go through one or two examples that are a little bit more complicated. So we'll make sure that we have a value for the slope that's not just 1, and we'll have a value for the intercept, for the y-intercept, that's not just 0. So we'll have a couple of different things to worry about. Maybe we'll make the slope a fraction and see where we can go from there. So maybe we'll call this lesson complicated graphing examples, something like that. So let's put that up at the top. Hopefully you guys can see this all right. This is complicated. Graphing. Examples. All right, so hopefully you can read that up there that says complicated graphing examples, and that will be the subject of today's lesson. So what we're going to do is we'll set up exactly the same way that we always do. We'll have our Cartesian plane over there, we'll have our equation over here, and we'll figure out how to turn the equation here into a picture over there. So let me start off by drawing out our axes. One familiar thing in perhaps unfamiliar setup. So we've got something like this. That x-axis is not very straight. Something like that. Does that look straight? That looks reasonably straight. Okay, cool. So we've got x over here. We've got y up there. Brilliant. And let's mark off some tick marks so that we know where we're going to have our points. 5, 6, 7, 8. So I've got 8 going in that direction. And what you might notice that I've done slightly differently this time is I've added negative values to my x-axis. I've extended my x-axis out this way. So when we started, we only were dealing with this, right? We were only dealing with something like that. Then we added in negative values to the y-axis. Now we're adding in negative values to the x-axis. So we've got something like this, and we'll put some tick marks going that way, and some tick marks going that way. So I'll give you guys a chance to draw those out, and it doesn't really matter if the number of ticks, up here and down here are the same, or on the left and the right are the same. It's a good idea if they're almost equal. So if you have like 6 or 7 on this side, then you should have something similar on that side. If you've got 7 here and 8 there, that's okay. But if you've got like 3 here and 15 on that side, maybe not the best. But depending on the equation that we end up graphing, it should be fine. So what I've got is, I think I've got 8 going that way. So let's number these off. So we've got 1, 2, 3, 4, 5, 6, 7, and 8 over there. Hopefully that's not too hard for you to read. And then over here we have -1, -2, -3, -4, -5, -6, -7, and -8. Going down from 0, -1, -2, -3, -4, -5, -6, -7, -8, and going up we've got 1, 2, 3, 4, 5, 6. So close to getting 8 in all directions, but you know what? We'll make do. What I'm going to do is I'm going to try and put some tick marks going down. Okay, that came out a little bit more of a solid line, but I think maybe it's okay. It's lighter than the other lines, so that's all that's really important here. Something like that. Just so we got some grid lines to help us out. You of course don't need to do this in your notebooks, but if you find that it helps you, then by all means go ahead. I'm putting these grid lines, these sort of thinner grid lines, every 2 squares, or every 2 units in a given direction. So I've got my y-axis here at 0, and then I've skipped 1, and then at 2 I've put one of these thinner lines, and then I've skipped 3, and at 4 I've put one of those lines. So I'm going to do the same thing going across, just so we have some nice proper grid lines. Like that. Good. All right, and a couple more down here. So of course the downside to me not having graph paper to work with when I'm teaching you guys is that it's going to take a couple minutes to set up the graph, but I think we're going to be able to make it work. So hopefully that is reasonably straight, and you've got something similar on your pages. If you're using lined paper, then these horizontal lines are always a good idea to use as sort of like a reference. So if you've got the horizontal lines on your page, then you could mark each of these off as 0, 1, 2, 3 when you draw in your axis, or you could mark points halfway between. So you have the lines that are on the page, and you mark off points in the middle, and you go 0, 1, 2, 3, 4, 5, 6. In the space of 3 lines, you could put 6 points. But however you guys have been setting it up, I'm sure that's going to work out just fine. So try and try and have your graph look something like what I've got set up here. So try and have that origin, that 0 point in the middle, roughly centered in your graph. So when we've got the positive x-axis, the positive y-axis, the negative y-axis, and the negative z-axis, when we've got all four of these directions here, try and keep that origin in the middle of your graph. Just it'll usually work out quite nicely with the equations that we're trying to deal with if you keep that origin in the middle. So what we're doing in this particular question is we're not necessarily going to be graphing something that needs us to be using all of this space over here. I just wanted to show you guys that this is what your full Cartesian plane looks like. When we started off with just a positive y-axis and a positive x-axis. Then we added in this part, and now we're adding in this part. So we're just extending this outwards a little bit. Down the road, if you guys keep doing math in the future, you'll end up working with an axis that sticks out of the board and comes out this way. So you have like an x-axis there, a y-axis there, and then like a z-axis, which it's kind of hard to draw on the board, but it's like it's coming out of the board, out towards you guys. So that's not something we're going to worry about right now, but what we will do is we'll try graphing something that we haven't quite done yet. So let's see, let's try doing, let me make that a little bit bigger just so that I can make sure you guys can see it, because we're in a little bit of an unusual situation. Let's do y equals 1/2 x let's do -2. Alright, so this equation is a little bit unusual. In case you can't see it up there, there's I think a little bit of glare from the light. I'm going to put it down here as well, in case it's easier to see down here. So we've got y equals 1/2 x minus 2. That's what we're trying to graph in this particular question. So we're going to try and do this with the shortcut. And the reason I'm emphasizing the use of the shortcut now is that in the next lesson, probably in the next lesson, we are going to start going in the other direction. So in this lesson, we're taking the equation and turning it into a graph. And in the next lesson, we're going to start with a graph and create the equation. All right, so right now what we're doing is I've given you this part, and I'm telling you draw a picture of this. And then in the next lesson, what we're going to do is I'm going to give you the picture, and I'm going to ask you to tell me what function generates that picture. What function is responsible for creating that picture? So the way to figure out what equation matches the picture, it's a lot easier if you just run the shortcut in reverse than if you try to go the other way. You know, the other way with our table of values where we have x here and y here, and we just pick a bunch of x values and run it through the function a bunch of times. We could do it that way. That's a totally valid way to solve the problem. But when we're trying to, if I just drew a line on here and I asked you to figure out the equation, the easiest way to go about that is to just take the shortcut and sort of run it in reverse until you end up with the full equation. So, in order to sort of make sure we're comfortable using the shortcut in one direction, we're going to solve this one using the shortcut, and then that'll hopefully kind of cement the idea of how the shortcut works. And then in the next video, we will start with the graph and we'll run the shortcut in reverse and generate an equation. So, when we're working with the shortcut, the first thing we need to do is we need to identify our slope, and we need to identify our y-intercept. Okay, so looking at the equation of a line, we know that normally the equation of a line, if we just write it with the letters, it's written as y equals mx plus b, where m right here is the slope, and b over here is the y-intercept. So, if we compare this equation down here using the letters to this equation that we are using in this particular question, we can just match up the placement of the letters with the placement of the numbers to determine what the slope and the intercept are. So if you have a number that's being multiplied by x, that number is going to be your slope, because down in this equation we've got m being multiplied by x. So if we've got m being multiplied by x down here, and m as the slope, then when we look up here, we've got 1/2 being multiplied by x. Or if you can't see it up there, over here, we've got 1/2 being multiplied by x. So that tells us that our slope is 1/2. So for this particular function, our slope is 1/2, which is something a little bit unusual because we haven't really dealt with slopes that aren't whole numbers. We've dealt with the slope of 1, we've dealt with a slope of 2, and we've sort of explored what happens if you have a slope of 1/2, but not so much with the intercept in place, and I don't believe we've ever solved it with the shortcut. So we've done a little bit with the slope not being a whole number before, but we haven't really done it with the shortcut, so that's why we're doing it with a fraction this time, to make things a little bit more exciting. Now the y-intercept is basically, once you've found one of the numbers from your equation up here, your other missing value is just the other number. So if you figured out the slope is this first number over here, then that number over there is going to be your y-intercept. Or if you figured out that this was your y-intercept, that number would be your slope. So the one thing you have to remember when you're writing down your slope and your y-intercept, especially your y-intercept, is that if you've got a minus sign right here, that minus sign needs to stick with the number when you write it down over here for your y-intercept. So our y-intercept, we've got the number 2 sitting out here at the end, but because the original equation has a plus sign and we are dealing with a minus sign, we need to carry that minus sign with us when we put it down here for our y-intercept. So our y-intercept is -2 in this particular question. So we've got a slope of 1/2 and we've got a y-intercept of -2. I really hope you guys can see that equation up in the top left, but if not, I'm rewriting the same thing down here. So anything I do up there, I will try to do down here as well. Alright, so now we've found our slope and we've found our y-intercept. So what we can do once we've found our y-intercept, really, that's the first key piece of information that we need, is this will allow us to plot our first point. So we plot our first point wherever the y-intercept tells us to. So the y-intercept has given us a value of -2. What does that mean? So think back to the last time that we did this. This number here for your y-intercept is telling you where on the y-axis to plot your first point. Why is it on the y-axis? Because we're dealing with the y-intercept. And we're dealing with the y-intercept here because we've got a y sitting out here in our equation. We've got the y sitting over there by itself. If we had the x over here by itself, then we'd be talking about an x-intercept, which is also a valid way to find the points for your graph, but because of the way we've set it up, that's our y-intercept over there, and based on this equation, we're being told to plot a point at the value of -2 on the y-axis. So if you go over to your plot, you look at your y-axis, which is this vertical one, and you find -2, you should be able to plot a point right there without too much trouble. Hopefully I've made that dot large enough for you to see. Just a reminder, my squares skip every other number. So I've got a line here at -8, and then a line here at -6, and -4, -2, 0, 2, 4, 6, 8. So I'm skipping one number in the middle every time. So that's why this dot is on the first line instead of being on the second line down because we're dealing with -2. But yeah, just a reminder that I have a little -1 sitting in there. So if your graph is set up differently and you've just got like 0 and then -1 on the first line and -2 on the second line, your graph's going to look a little bit different on the page, but just keep in mind that I've set mine up slightly differently just so I can include a few more numbers. All right, with that out of the way, we can now plot our next point. But in order to do that, now we need to utilize this piece of information, the slope that we found from our equation. So what I'm going to do is I'm going to get rid of this stuff down here. All right, now we know our slope is equal to the rise over the run. Now in this particular question, we don't have a slope that is a whole number. Instead, for this particular question, we've got a slope that is a fraction. So slope, which is equal to rise over run, in this case is also equal to 1/2, because that's the value of the slope that we found from our function up here, or our function over there if you prefer. So what this information here is telling us, this section right here, this is telling us that if you just match up the two numerators, so this rise and that 1, if you match up the two numerators and you match up the two denominators, this is telling you that every time you go up, so every time you go up 1 unit, you have to go over 2 units. Okay? So the way this works is the numerator tells you how many units you have to go up, and the denominator tells you how many units you have to go to the right from your first point on the graph. So we've already got a point sitting here at 0, -2, and now we need to use this information to plot our next point. So what this is telling us is for every unit we move up, we need to move over 2 units. That's what we're being told here. So for every unit we move up, we have to move over 2 to the right. So if we start from here at -2, we move up 1 unit, that brings us up here to -1, which might be a little hard for you to see from over there. But so from -2 we moved up here to -1, so that's taking care of our moving up 1 unit. That part's done, check mark. Now we have to move over 2 units to the right. So from here we move over 1, that puts us right there. We move over a second one, and that should be where we put our point. All right, so what this lets us do, this is actually enough. Once you've found that second point, this is actually enough for you to draw a line that just passes through those 2 points, and technically you would be done the problem. Just to give us a little bit more practice, we're going to run through this process again of moving up 1 unit and then 2 over to the right, and we'll plot a second point and we'll plot a third point, and we'll keep going until we've got a couple more points down on there on that graph, and then we'll draw a line that's connecting them all. So from this second point right here, our next step is to just repeat this process, just rinse and repeat. So from this second point right here, we're going to move up 1 unit and then move 2 units to the right. So from here, we move up 1 unit and then we move 2 units over to the right, and we plot a point over there. Now, because this might be a little hard for you guys to see because of the way I've drawn the graph, maybe I should have used less numbers. Next time I'll space out the numbers a little bit more. I was envisioning something a little bit different when I was drawing this, and then changed my plans at the last second. It might be a little bit hard for you guys to see. So what I will do is I'll write in the coordinates of these 3 points, and then we'll draw a line through it. So this first point, its x-coordinate is 0, because we haven't moved left or right from our origin point. We haven't moved left or right, we've only moved down. So our x-coordinate is 0, and our y-coordinate is -2. That's for this first point over here. For our second point, our x-coordinate is 2. We've moved 2 units to the right. And our y-coordinate is -1. So down 1 unit from the origin. Or if you prefer, from over here, we went up 1 unit, which I know it's a little confusing. It's the second number is telling us whether we're moving vertically or horizontally. But we moved up 1 unit, so -2 becomes -1. And then we've gone 2 units to the right, so 0 became +2. It's a little bit confusing to think about it that way, and I apologize if I haven't explained it in the best way possible. I haven't slept yet, so that's on me. But hopefully this is making sense. And then just for the sake of completeness, this third point up here is at an x-coordinate of 4 and a y-coordinate of 0, because we haven't moved up or down from the origin. We've only moved left and right in this for this particular point. So that gives us those 3 points right there. Hopefully you can read those numbers. Looks okay from where I am, but I know with you guys sitting in a classroom, looking at a screen, looking at a blackboard, it might not be quite so easy. So I'll try and work that out a little bit better for the next one. But yeah, once you've got a couple points down, that's enough for you to draw a line through it. For the sake of practice, we'll do one more point. So from here, we can go, again, following this set of instructions. From here, we go up 1 unit, so that takes us up here. And then we go over 2 units, and that takes us to right over there. Which, if we write out what that point is, it's at an x-coordinate of 6 and a y-coordinate of 1. So if you notice, if you look at these 4 points, I know the numbers are kind of written everywhere, but if you look at, this is our first point, second point, third point, fourth point, the x values go 0, 2, 4, 6, and our y values go -2, -1, 0, 1. So there is a pattern to how the x and y values change from one point to the next if you just keep using this system. So we could generate the next point just by following the pattern. The x values went 0, 2, 4, 6, so the next one should be 8, right? And the y values went -2, -1, 0, 1, so the next one should be 2. So I should be able to plot a point at 8, 2, and that should also be a point on this line. And if I do that, sure enough, we go to 8 on the x-axis, 2 on the y-axis, put a dot right there, and it looks to me like it fits right on that line as well. So now we've got a whole bunch of dots. We can connect those dots with hopefully a straight line. Let me give this a go, and we'll see how this turns out. Something like that. And that is your line. That is your graph of the line y equals 1/2 x minus 2. Hopefully that came out kind of straight. Yeah, so it is a little bit of a process to use the shortcut, but once you get the hang of it, it's so much quicker than using the table that we were using originally. So hopefully you found the shortcut to be helpful. I think we're not going to get through a second example in this video because we're already approaching the half-hour mark, and that's definitely my fault for probably explaining this slower than I should have, but I want to make sure that you guys are understanding the graphing side of it before we take it in reverse. So what we're going to do in the next one, we'll take it real slow. We'll probably just do one example in the next video, and we'll just take the same idea, the idea of this shortcut that we've been using, and we'll just run it in reverse. So I'll start off by drawing the graph, and I'll put down a few points. We'll draw a line, and then we'll work together to figure out an equation. All right, so yeah, hopefully you guys found this helpful. Please let me know if the audio is off or the video is off. As it stands, it's 5:41 in the morning. So I will, my plan was to record this one, and then while this one is uploading, record the next one right away. So if the audio is off in this one, the audio is going to be off in the next one, and same with the video quality. If the video is worse in this one than it normally is, it's going to be the same quality as this video in the next one, because I am not moving my laptop between recording this one and recording the next one. So if you guys do have feedback on that, please let me know as soon as possible so that I don't set up like this again if there is a problem. But otherwise it should just be this video and the next one, and then we'll be back to the old system with my whiteboard in my room with the headphones and all of that, which is a sort of tried and tested system. So we'll be back to that real soon. Hopefully this isn't too inconvenient for you guys, and hopefully the material is making sense. That's really the most important thing, is that the material is making sense. But yeah, if there's anything that you guys would like me to change in terms of the setup of the videos, if you prefer the Blackboard, if the audio or the video or both seem to be better this way, then I can absolutely start recording more of the videos using a Blackboard here. It's something I definitely would not mind doing, and I'll just have to work it into my schedule that I come here at the same time every week so that the classroom is free, hopefully not at 5 in the morning. But yeah, if you guys have any suggestions for something that I should change with the setup, then just let me know. But if not, I will see you very shortly in the next video. Have a good one.